Alright, welcome to section 2 of chapter 5. Turn it up to 11. So we're going to turn it up a notch. The proofs become longer in this section. There's not a lot of new material. I'll introduce what is new towards the bottom of the first page here. But as you'll see on the first proof that we do, as well as the two that we're going to try on the back, the proofs are going to get a little bit tougher and a little bit longer. So let's take a look at this first proof here. And as we're looking at this proof, and you're looking at proofs that are longer, you have to make sure that as you approach these, you really plan these out and that you are working backwards a little bit. So here's what I mean. A lot of given information here, which we can mark. So EHS is congruent to this. Okay, I might, just by looking at that, see that these angles over here are congruent to each other. Angle D is congruent to CHT. These are congruent to each other. Angle A is congruent to RSA. So these guys are congruent to each other. You have a bisector. So this is a bisector, and this is a bisector. Two bisectors might clue me in that maybe I'm going to do something with multiplication or division property. And the last given information is that DS is congruent to HA. And I'm looking at that, I see two segments that are overlapping with each other. So I might have some sort of a subtraction property there. And what I'm trying to prove here is, use green, is that these two segments are congruent to each other. That's where I'm trying to get at. So when I look at this, I'm thinking that probably, maybe, I'm looking at these two triangles down here. Okay, so let's see if we can get those two triangles. If I get those two triangles, then I'm looking at CPCT-seeing to get the green dots congruent to each other. So right off the bat, I know that this is congruent to this. That gives me one piece already. And because I know that these were congruent to each other, we know that the entire length here is congruent to this entire length right there. And we said that, remember, we got two bisect statements, so that would probably give me that these two angles down here are congruent to each other. Okay, that's going to be just by division property. And then I know that all these angles down at the bottom here are going to be all congruent to each other, including these two. That's going to be some transitive property. Okay, so just kind of scribble some notes down there. I know that, for example, angle EHD is going to be congruent to angle LSA. Subs of congruent angles congruent. I can also do that by subtraction property. And then I also know that angle CHD is congruent to angle RSA, and that would have been by division property. And then hopefully I can see here that I got these givens right here. And here. And together with this, I can combine everything together and I can get that angle D is congruent to angle A. That's just going to be one gigantic transitive property. I got DH congruent to SA, and that was by subtraction. Triangle's congruent, therefore by angle side angle, and then I can CP/CTC it to get that. Okay, hopefully you can see that there's nothing really new there, but it's just a lot of steps and a lot of thinking involved. And what we did was we kind of worked backwards a little bit there. We worked forwards, and we also thought about it working backwards a little bit. Okay. So in this section, they're going to bring back altitudes, medians, and angle bisectors, and perpendicular bisectors. Actually, bisectors of all types. Altitudes, of course, is when you have a segment drawn perpendicular to the opposite side of a triangle. Medians is when you have a segment drawn to the midpoint of the opposite side. Perpendicular bisectors are perpendicular and bisect each of the sides. And then there's this concept down here called auxiliary lines. Okay. So when you have a proof like this, and I can just, by looking at the diagram here, I can see that, okay, we're going to have a little bit of a problem here. And the reason why is because everything we've been doing up to this point has been with congruent triangles. And I don't have any congruent triangles down here. But you want to prove that AT bisects angle A, and there is no AT. So what you're going to have to do is do what's called drawing an auxiliary line. So as a step here, you're going to say draw AT, that's an auxiliary line. And the reason you're going to say is 2 points determine a line, or in this case it's a line segment. And then you would just continue on like we've been doing all the proofs. You got a reflexive here, you know that AM congruent to AH, MC is congruent to this, SSS, AT bisects angle A, so this is congruent to this by CP/CTC, and then you can see that that's going to give you the angle bisector. Now, what always happens at this point in the year is that students go crazy with auxiliary lines. They just, whenever they get stuck, they just start going, I'm going to draw auxiliary lines everywhere. Be careful, okay? Danger, caution, don't get carried away. Most of the time, most of the proofs you're going to be doing do not have auxiliary lines. Really, the only time you need an auxiliary line is when it looks pretty obvious that you're missing a line segment, or you might have a circle where you're missing a radii, for example. Okay? Let's jump to the backside now and try a couple more proofs. Alright, we're on the backside now. We're trying some of these tougher proofs. Let's take a look at this first one here. GE is perpendicular to AD. A right angle right there. I know that AD is an altitude, so I've got a right angle here. AE is congruent to BD. Okay, that's kind of weird. But let's go with that. And ABC, CC, is congruent to BAC, this big angle here. And you got two bisect statements. Ooh, okay. So I'm looking at these all put together here, and I'm thinking it's either multiplication or division property. And in this case, it has to be division property because the entire angle is congruent to this entire angle here. So let's see if that would be useful. Alt or division. And we're looking to prove that AG is congruent to BE. Okay, and as I'm looking at this, I'm looking at where all the markings are. It looks to me, and hopefully looks to you, like these two triangles are the ones I need to prove congruent. And the weird thing is, it doesn't look like a lot of the diagrams that we've been doing up to this point. So let's go ahead and do this. I know that this is going to give me right angle, as well as this is going to give me a right angle. And we know that the right angles are congruent to each other. Okay, that gives me an angle. It's given that these are congruent to each other. That's a side right there. And so I know right away that I'm looking at probably an angle here, right? So I'm going to look at all this information here, and I'm going to end up with angle GAE being congruent to angle DBE. That's just going to be by division property. Okay, so I know that this angle is congruent to this one by division property. That gives me yet another angle. So triangles are congruent by angle side angle, and then CPCTC gives me that. Okay, and that's what I would do. Is I would map it out off on the side, or plan it out. And once I've planned it out, I would go ahead over to the 2-column section over here, over to this section over here, and I would go ahead and write out incomplete, in full, the 2-column proof. Okay, this next one here is DC is perpendicular to AB, right angles, CD bisects ACB, congruent. Looks like I got reflexive there. That gives me these two triangles congruent. Right off the bat, I can prove these two right here are congruent to each other by angle, side, angle. Once I get that, I take a look at what I'm looking for. And what I'm looking for here is I'm looking to get angle 1 congruent to angle 2. And hopefully you can see that those aren't the CPCTC angles from the triangle, but these are the CPCTC angles from the triangle. Once I get those, I can get these two angles either by subtraction property, okay, subtracting the CPCTC angles from the straight angles, or I can do subs. Subs of congruent angles are congruent. Okay, I'm going to stop there, let you try some of these tougher proofs on the homework. Good luck with it. All right, take care.